All right, so this is group number 5. My name is Victoria. My partner's name is Brandon. And here we go. All right, so for group 5, we had these measurements here. To find the volume, I used length times width times height. But to start, I took all of these millimeter measurements. I converted them to centimeters by dividing everything by 10. Once I got that, I got volumes in milliliters. Once I had volume, I took the mass measurements, divided them by the volume, and then got these density measurements. Once I got the density, I added all of these up, divided them by 4, which gave me 2.29 grams per milliliters. When looking at the density measurements, we can see that the first 3 are very close together with very minimal differences. However, the 4th measurement varies quite almost dramatically compared to the other ones. This could have occurred for any number of reasons. You see that it may have been a different material, it may have just been a different size, as we can also see that the mass is quite larger and the length is a lot larger. These could have been errors, and then maybe we were looking at the wrong point when measuring the length, or maybe the scale was not zeroed out when determining the mass. But regardless, these were the density measurements that we were given, which gave us our average and so forth.
Hello, my name is Brandon Kamen. I'm part of Group 5, and I'm here discussing my part of the project. So I plotted this graph by taking these dataset values I got from my fellow associate, my group project Victoria Briggs, and I had inserted them into a plot chart scatter here, and got these results. And I plotted them with mass on the bottom in grams and volume on the left as my y in milliliters, because we have us calculate as grams per milliliters for our project, and that'll be that there. So as you can see, the points are plotted, their x and y values are given for where they are on the graph. And for our trend line, I had clicked this and gone to trend line here. I went to more options, and I initially used a linear, which gives a false result, and I found that using exponential was the correct choice, as it gave us a more accurate x given for our average grams per milliliter, because it's slowly curved up. If you go linear, it gives you a huge 55% marginal error, so I had that changed. So the values that I got for our x, I think the reason why the values are so different is because we have a little bit of outliers in our given averages. So we have this one down here below our trend line and this one way above. And these two values setting us off. If we had more x values given for our average density, we'd probably reach a value more closely given to our average density. And I calculate this to have a 6.99% error for trend line. So not major, but it's there. And when given the calculation for our aluminum, I had taken the aluminum grams per milliliter given. I subtracted by our x, which is 2.4526. That is a very small power. I believe that's just how the Excel is given it. So I simply subtracted the main value I could see with a little bit of marginal error. With the value given, I divided it by 2.710 our aluminum to get this value of 0.0950 times 100 to now get our final error, which is 9.500 error for aluminum. It's quite different, but it's not a huge marginal error. And with that, that is my portion of our group project.